Welcome to exercise 2, where we're going to look at sourcing some online spatial data. So spatial data, like we've already discovered, we can get our remote sensing imagery from web servers, and quite a lot of government organisations tend to store spatial imagery and other data such as climate, elevation, soils data, slopes, in web-based databases that are often available free, or within your organisation sometimes you've got access to particular databases that the public can't get to. So those particular agencies are known as the custodian of the data, and like I said, sometimes you have to pay for it, sometimes it's free, and sometimes it's only available to private users. So what we find with a lot of the spatial data out there is, if it's really good data, they've also got metadata, and metadata is an information in a particular file that tells us about what that spatial data is, when it was collected, who it was collected by, the parameters that were used to collect the data. And that's really important when we start thinking about using the data, because we need to understand how this data was put together. Was it point sampled, every 500 metres? Or is it more accurate? It's come from sampling that was done every metre, so we can have more reliability in the particular data set. So getting that bit of an understanding, we can often find that information in our metadata. So the first thing we're going to go and have a look at is the New South Wales Spatial Data Catalogue, and you can see here that there's a number of spatial organisations where we can get spatial data from. And so I encourage you to go and click on some of those links and have a little bit of a look at some of the spatial data that's available. And certainly in some more of your subjects through your course, you're going to be required to go and get some of this data. So it's a good time to have a bit of a look and have a bit of an understanding of what data exists and where you can get it from. Likewise, doing a free GIS data web search, you can see that there's a bunch of places that provide different quality data and different types of data. And again, a little bit of a Google search and you can start to see that there's a stack of data out there. You've just got to go hunting for some of it. What we're going to do is we're going to use web coverage services that are embedded in QGIS to actually extract some of the data that we're interested in. And so to do that, the first thing we're going to do is open a QGIS project. I'm not going to follow the instructions exactly here, because you can load a new satellite imagery and navigate to the farm like it suggests in the instructions, set your scale and create a new vector file. I'm just going to use the same QGIS file that we were using before and create some new paddocks based on that file. I think it'll be a little bit easier to work with and a little bit more informative, seeing you're already used to this. But if you want to set up a new project, and again, we've shown you, go down to Open Layers plugin, bring in your big maps with labels, and then we'll go and create a new vector layer to create our new shape file. We'll call it soils, or we'll call it paddocks, and we'll add a field to the list. Actually, I might make that a capital, and we'll add fields to the list. So we've got one field in there already, and we'll make it polygons because we want enclosed areas that encompass a paddock. And we're going to call it, I'm going to save it to ArcTemp again, and I'm going to call it soils paddocks, because we're going to go and get some soils data to put into this file. So now that I've created my shape file, I'm going to go and edit that file and create the actual paddocks that I'm going to add some data into later. So I'll click on my yellow edit, and you can see that it's come down in my soil paddocks. I'm going to click on my add features tool, and I'm just going to draw a boundary around any particular paddock. It doesn't really matter. You can copy what I'm doing if you like, or you can create your own. Let's do that again because I didn't finish doing my box correctly. Right, click on that. We'll give it a paddock ID of 10, just not to confuse it with the other ones, and we'll call it soil 1. Alright, we've now got a 1 paddock, and we might do this one up here. And I'm going to give it an ID of 11. I'm using those numbers just because we've already got IDs 1 through to 5 used, so I'll just give myself some other options. It's not critical. I could have just continued on and called it 6 and 7, but that's done. And then I'll click off this toggle and it'll ask me if I want to save that change to the soils paddocks layer, and I'm going to say yes, save it. Now, of course, this is all going to be saved in my original project, and that's why the instructions here, just to keep your original project separate from your from this exercise. But it really doesn't matter. I'm quite happy to have them both combined, but just so you know the difference. And of course, if I didn't want to display that one, I could turn it off and turn it on using this particular tool here. So now, because I want some soils data, we're actually going to go to a CSIRO site, Soil and Landscape Grid of Australia, hosted by CSIRO. The web address is given in your tutorial guide. So go to that site and then go to the Get the Data and Direct to GIS tabs. Click on those and it'll bring you to this particular page here, which will show you a whole list of data that we can add to our QGIS. But just before we do that, we can have a bit of a look at the data is being put together by the Open Geospatial Consortium, OGC, and they're basically a consortium that looks after the standards of how data is put together for particular different sources. So you can see that you know, it's a consultative process where they talk to the geospatial community to make sure that they're using a set of standards so all data is similar in the way it's distributed. And we're going to be getting the data through a web coverage service that's linked directly through QGIS. So you'll see what I mean when we get to that particular part. But what you can see is that the soil data has been created in individual GIS layers, and only one attribute is shown in each one of those layers, and these links go to that particular server for that particular attribute of soils data. So if I look here, this title here tells me that this is national soils data, and I've got a whole heap of attributes: clay, silt, sand, pH, etc., etc. These are regional soil attributes of Western Australia, South Australia, Tasmania, and so on. So there's a bunch of data there that you can use, and then there's also some instructions down here on how to get that data using QGIS and their web coverage services. So to get our data from the server into our actual QGIS, we click back on QGIS and we can access the WCS server either by clicking this particular button here, which will open and add layers from WCS server, or we can go to layer, add layer, and then find the same button, add WCS layer, in the same fashion. So the first thing we need to do with this particular box is create a new connection, and we'll call that one CSIRO. Let me try that again. CSIRO soil landscape underscore underscore grid. So we'll try that again, grid underscore national clay. And now what we need to do is link that to the actual server address. So if I go back to the web page that we had up before, you can see that there's for the clay attribute, there's a web address there. So if I just go and highlight that web address and copy it, and then I can go back to my server window. I better show you that again. So create that CSIRO soil landscape grid underscore. Sorry about that before, I had it on the wrong screen. I just realised you wouldn't have been able to see it. And then that web address that I copied, I can just paste straight into the URL field. Now, sometimes these servers will need some authentication, a username and password. In this case, because it's free, we don't actually require any of that. So if I just hit OK, it should start to upload that particular data when I hit connect. So it's trying to connect at the moment, and we'll see what actually happens. You can see that it's connected and it's got a whole heap of fields there. So now that we've got the actual data to our connected to our QGIS, what we actually want to do is add that to our layer. And so we're going to actually select the field that we're interested in. So in this case, we're going to choose the clay content of the soil within the 5 to 15 centimetre depth layer given as a percentage. So we'll highlight that one and we'll add that, and what you'll see in your layers panel is that that layer has actually been added. So I can close that connection down now, and we can see in our soils paddocks we now have information about our particular clay layer as a percentage in those particular areas. So difficult to see where our paddock boundaries are, so what I might do is drag our paddock boundaries over the top of that particular map, and I can also drag the old paddock boundaries that we had above that layer as well if I was interested in doing that. And again, like I showed you in the first exercise, you can adjust transparency so you can see through those layers a little bit more effectively, etc., etc. I'm going to rename this layer by clicking on the actual for and changing the name of the layer there to clay percentage, just to and bring that over so you can see what I've done. In general, clay percentage, and I've clicked apply, OK, and you can see that that layer has now been adjusted to reflect clay percentage. I'm going to click on my soils paddocks layer and just adjust the transparency, so I would like to be able to see what the soils layer is doing under those particular paddocks. So I'll click apply and then OK, and you can see now I can start to see some of the data. If we look on the legend in our layers panel, we can see that the clay percentage layer ranges from 0 to 41.7ish, and so 0 being black and 41.7 being white. So it's a graduated scale, and we'll try and find out a little bit more information about what the exact values are shortly. So what I might do now is actually zoom in on one of these little paddocks just to get a bit of a closer look at what we're actually looking at. And I'll move across so I can find that paddock again, because the zoom didn't seem to take me to where I wanted to go. So we can see that there's some variability within those paddocks. Now if I change in my layers panel to the actual clay percentage layer, and I use this little information tool up in our main menu, you can see that when I click on one of these raster pixels, it's actually going to give me some information. So it's telling me that the clay percentage for that particular pixel is 31.3%, 3% or 4% rounded off. And likewise, if I go to a brighter one, it increases to 34, And if I zoom out a bit, we'll try and find a darker pixel somewhere in our image, say this one down here. You can see that drops down to about 23%. So we can start to get a feel for clay percentage variability, and obviously within that source data there's a bunch of other attributes we might be interested in. So this is free data, so if you wanted to have a bit of an understanding of what was going on around your particular farm and you didn't really have access to data, you could obviously go to a site like this and get some information about the clay content of the soils on your particular farm from a national database. It'll be quite coarse, but that being said, it's still data that puts you in the ballpark of what you're dealing with, so not a bad little bit of information to have when you're starting to try and manage the soils on your farm. So what if we wanted to put some information actually into our GIS? At the moment all we've got is a boundary around a particular paddock. We can see that there's some variability across that particular paddock. What if we wanted to know what was the average sort of clay reading across that paddock? Well, first of all, we'll go to our soils paddock layer that we've added in, and we'll open the attribute table to see what we've got in there. And we can see that we've got two IDs, one field, and what we're going to do is add in a new field, and we're going to call that field clay percent, and we'll make it about 3 because we're only dealing with reasonably small numbers, and we'll click OK, and you can see the new field. It hasn't been populated yet, but you can see the new fields being added to our attribute table for that particular layer. And for the sake of this exercise, there are more advanced techniques where we could actually sum all of those particular pixels from our soils data and average them out using an expression that we would build using various tools within QGIS. But just to demonstrate the basic principles, if we just have a bit of a look around here, we can sort of see most of the values within this are around that 33, 34, a couple of low ones. So if I said that the average value for that particular soils paddock was about 33, we go back to our attribute table and it's still editing, so we could put in for that particular paddock 33 as an average clay percentage. As I said, you could get a bit more technical and do it either manually by adding all those pixels up and dividing by the number of pixels, or you could create an expression using your field calculator and some intersections between the polygon that you've created and the raster layer to extract out what the exact average is. But that's a little bit more complex for what we need at this stage of the subject. So we've updated that one. If I did the same for soil 2, I'll just hypothetically put in a value of 36. We can now save those edits. If we click on the pencil to stop our editing, it'll ask us what we want to do, and I'm going to save those. We could do the same thing. We could create another, I'll edit again, we could create another layer called area, just like we did before, and add that in as well. I'm not going to do it here, but you can sort of get the drift of where we could go. We could add in new fields to this particular layer as well. Alright, so we'll close that one down. We've now entered in that particular soil information, and we're still editing that layer, so I can turn that edit off. And what I might do at this stage is go and save our project, so we might click save. That way, if QGIS was to fail for some reason, we've actually got a backup. And it's not a bad idea whenever you add some new data or you draw some new, do some new digitizing within your QGIS, that you keep hitting save as you go along, just so that if you do get a crash, lots of open source software sometimes can conflict with other software that you've got installed on your computer, and it can crash sometimes. So most of the time you've seen so far, it's been pretty stable with what we've been doing for these exercises. Finally, to wrap up this section, we can also look for data from different sources. So we're quite often interested in climate data. Some of that can be imported into QGIS if you know where to look. Other times it's just as easy to go and have a look at at the Bureau of Meteorology just to get a feel for your particular data set. So if I open up a web browser and take us to the Bureau of Meteorology, the web address is in your tutorial, or you can see it in this presentation. And if I select, you can either select using text or you can select using a map. I prefer a map. I'm a bit more spatially or visually orientated. And I'll just zoom to Wagga down here. That'll get me to Wagga. It should update the map. It might take a few seconds while it collects that data from the server. Select Wagga, and you can see that our CSU, Wagga Agricultural Institute, which is next to CSU, has a weather station on it that collects regular weather readings and gives those to BOM. And if I go to map layers, I can actually select average annual rainfall, and it'll give me a map that shows us the average annual rainfall, which is about sort of around the 550, sort of bordering between Wagga and the Institute is around the 550, 600 mark millimetres per year. So again, I can zoom out and see if that sort of trend changes. Obviously, as we go more westerly, we start to get less and less rain, and as we go towards the mountains up here at Humula and Tumbarumba Tumut, we start to increase our rainfall as well. So we can obviously take that data that we've got there. We don't have to do average. We can look at other things like elevation, and so you can see that change in elevation is driving a bit of that rainfall that we're seeing. As we look there, we can look at the temperatures as well, and a whole range of data. So if we wanted to input that into our database, we could create a new field called temperature, and we could either enter in daily rainfall data, or in this case our average annual rainfall, etc., etc. Now there's a whole heap of other sites, and I suggest that you go out and have a bit of a web search for some of the spatial data that's available online. In particular, your topography, your soils, your temperature, and DEM data that might give you information about your slope and aspect of the mountainous terrain in your area, as well as your overall elevation. If you record some of that, and you might start thinking about what you might be doing in your course and start adding data for your particular farm. I know in a few of the subjects you'll be asked to look for data corresponding to a property that you might manage, or that you might be looking after or interacting with. So it's a good idea now to have a little bit of a browse and see what data you can find that's freely available, and if it's not freely available, what access you can get to some of that data for your future. Alright, that wraps up this presentation, and we'll move on to the next one.